Welcome to Let's Calculate Something. Today we have a pretty cool calculus problem where we're going to try to find the maximum volume of a can that we can create using 50 centimeters of material for both the side part and the top and the bottom. And so to do that, we're going to use calculus. We're going to use a derivative function, and when we're going to be able to set that derivative equal to 0, solve for one of the variables, plug in for the other variable. So let's start by figuring out what the volume of a cylinder is and what the surface area of the cylinder is. Okay, so with the volume is going to equal the area of the top or bottom times the height. So that would be pi r squared h. And the surface area is going to equal pi r squared, which is the surface area of the top, times 2, because we have to cover the top and the bottom, plus the surface area of the side, which will be the circumference, which is 2 pi r, times the height. Okay, so we have two equations now, and we know this equation is, we know that it's equal to 50, so we'll put that up here. Alright, and we have now an equation in h and an equation in two variables. One h, the height, we don't know that, and we don't know r. But we have two equations to try to figure that out. And so what we'll do is we'll kind of try to see. We have an r squared term, an r squared term, and we have an h, just straight up h, raised to 1 power, not a quadratic. So it's going to be a lot easier to solve this for h and plug it into this function. Okay, so let's do that. So if we start to simplify this, we try to isolate this h. We have h equals 50 minus 2 pi r squared divided by 2 pi r here. Alright, and we can simplify that a little bit. We can get rid of the 2, and this will be 25, and we can get rid of the 2 here. Right? So that simplifies to h equals 25 minus pi r squared over pi r. Okay, so we got the h simplified down now. We have h in terms of r. So let's plug that into this. So we have the volume equals pi r squared times 25 minus pi r squared divided by pi r. Okay, so now let's multiply this through and see if we can simplify this. The volume will equal 25 pi r squared minus pi squared r to the 4th divided by pi r. Okay, so now what we need to do is try to simplify this. So we can see immediately that the pi r can divide into both of these. We can get rid of this, we can get rid of this, and that brings that down from a second power to a first. You can get rid of one of the pi's, okay, and we can make this a cubic. Okay, so now we have volume equals 25r minus pi r cubed. Okay, So that is an important equation along with this piece here. This is H. Okay, so now we have H, and we also have the volume. So we can take the derivative of this volume and set it equal to 0. We can find the radius that's going to give us the maximum volume. So if we were to take dV with respect to r, it's going to equal 25 minus 2 pi r squared. Sorry, 3 pi r squared. Okay? Now if we set that equal to 0, and then solve for r, r will equal minus 25 divided by minus 3 pi and the square root of that, really the plus or minus of it. But we know, so these will cancel, so we really have 25 over 3 pi, the square root of 25 over 3 pi, and we know we're not going to need the negative, right? That negative, we don't have a negative radius, so we know it's just the positive root, and that equals 5 divided by the square root of 3 pi. So that will be our radius. And it's kind of a strange number, but it is the radius. And so now that we have the radius, circle that in red, now we can plug that right back into our height. Our height. And so if we do that, we have the height equals 25 minus pi times 5 over the square root of 3, 5 over the square root of 3 pi squared divided by pi times 5 over the square root of 3. 3 pi, I should say. Okay. So now we can simplify this, and that will equal 25 minus 25 divided by 3 pi times pi divided by 5 pi over the square root of 3 pi. Alright, so now we can cancel these pi's, and if you calculate this, 5 divided by the square root of 3 pi is 1.63. Now remember, that's the radius. So the diameter is going to be twice that, and that is 3.25. Okay? And then if you do this math here, the 25 minus 25 pi over 3 and divided by 5 pi to the square root, divided by the 5, yeah, this mess also equals 3.25. So it's kind of interesting, and this happens sometimes in geometry problems, and that is that we have the maximum volume for for this can is where the diameter equals the height. And that would be 3.25 centimeters for both. And that's the answer. So we were able to use differentiation, use some geometry to figure out the area and volume of the can, use some differentiation, come out with some pretty funky numbers in terms of pi and quotients, etc. But at the end of the day, the diameter and the height are the same, and that's the answer. Thanks for watching. Please like the video and subscribe to our channel. And also, if you can click the bell for the notifications, we're going to have lots of videos coming up, and you can see more of them as they come out. You'll be notified when we post them. So thanks a lot, and we'll see you next time.